This video is going to look at refraction, or how light bends. So refraction occurs when a wave moves from one medium into another and changes speed. So it's a result from changing speed going from one medium into another. And the change in speed results in the direction of the wave changing ever so slightly. So it was going, say this way, and now it's going that way. And this is because of the change in speed. The reason why, you can imagine kind of this analogy of, say, you've got a little toy car. So these are the wheels. Now, if this toy car is driving, say, like this, and say this is sidewalk, and this is grass, and the wheels are going to roll more easily on the sidewalk than the grass, right? Well, as this wave gets, or as this toy car gets to the grass, these wheels on the right side are going to hit the grass first, and they're going to slow down the right side of the car. The wheels on the left are going to keep going at the same speed. So what ends up happening is the left side goes faster than the right side, and the car itself kind of spins or turns, and then it ends up going straight, because once the wheels on the left hit the grass, then everything's on the grass and everything's going at the same speed, so it goes in a straight line again. So it turns at this point where it's changing media, or changing from the sidewalk to the grass in our analogy. So that means we need to calculate this thing called index of refraction. So the index of refraction for a medium is defined by this ratio. So n is equal to c over v. And this is, by the way, before was for any wave. Now we're talking specifically for light. This n is the index of refraction. So it's just the symbol we use is n. C is the speed of light in a vacuum. And that is defined by as 2.998 times 10 to the 8th, I believe, meters per second. But for this class, you can just use 3 times 10 to the 8 meters per second. And then v is the speed of light in the medium. So in water, it travels slower than in a vacuum. In air, it travels slower than in a vacuum. So you find the ratio of those two, and that lets you calculate n. So now, light travels fastest in a vacuum. So in any other medium, it travels slightly slower. And so because that c is always going to be bigger than v, n should also always be bigger than 1. Because the numerator will always be bigger than the denominator. So n is 1 for a vacuum, but for any other substance, n should be greater than 1. And this will be useful in the next step. For now, it's just like, if you're like, what is the point of this? You're right, there's no reason to know this number other than it lets us talk about Snell's law. So refraction can be calculated with Snell's law, which states that the index of refraction in one medium times sine of the angle that it's traveling at in that medium should equal the index of refraction in the second medium times the sine of the angle in the second medium. Or sometimes you see it as sine of the angle in one medium divided by sine of the angle in another medium is equal to the velocity in one medium divided by the velocity in the second. So both of these are the same because, again, n is just the speed of light. N is equal to c over v, so you can plug in this, cancel the speed of light, and then cross multiply the velocities, divide the signs to get that. So now, what does all of this mean, or like where does this all come? So if you look at this diagram here on the right or on the left, you have the interface, or this is the difference between the two mediums. So say on top this might be air, and then down below this might be water. So what we have then is there's a surface, or the interface between them. And then there's also this normal, which is a fancy word for perpendicular line. So if the light is coming in at this angle relative to the normal line, theta 1, when it gets to the water, it slows down and it bends. And it slows down and it bends towards the normal line because it slows down. How do we know how much these various things should be? Well, they're going to obey Snell's law here. So this shows you if n is bigger, then the sine of the angle has to be smaller, because they have to kind of be equal. So in other words, the slower medium has a smaller angle. The faster medium has a bigger angle. And this is something of just practicing and playing around and calculating it, you get a feel for it. But the important thing to remember is theta is always relative to the normal or perpendicular line. So it's not relative to the surface between them. It's always relative to that perpendicular value. So you've got a couple things that'll help you practice with this, but if you have questions, please feel free to ask. And yeah, it's just either one of these will work. It's just whether they give you the speed or the index of refraction.